Right, and I've got a little bit of a piece of paper here to start us with. So I'm going to draw you a couple of pictures before we start, and just to give you an idea of what we're doing here. So the idea here, all right. So the idea here is that we're going to have some kind of a weird function, all right? When I say weird, I mean like y equals square root of x or something. And what we're going to try to do is we're going to rotate it around an axis, okay? Let me rotate. Now, normally, right, the normal problem you do is around the x-axis, but there's no reason why it can't be around the y-axis or some other axis, okay? But what we're trying to do here is we are rotating this thing around this axis here, all right? Now, what's going on in theory is that we have a whole bunch of these little cylinders, right? And we're going to add up, right, all of these tiny little cylinders, and that's called a volume of revolution. So you think all of these guys are going to be stacked on top of each other. So normally our volume for a cylinder, right, that's going to be pi r squared times h, all right? So the radius, that's this distance here, right? This is your radius. This is the function. This is y equals f of x here. Okay, so my radius is the function value. The tiny little h's, right? These are going to be all your little h's here. That's going to be your dx. So here's your f of x is r, and then dx is going to be my h. So the formula that, you know, I would recommend like thinking about a cylinder and how to add all of the cylinders up. But I also understand that, you know, especially the first couple of times you do it, you know, you might want the formula, right? So it's pi r squared h, okay? Now, the reason I would recommend like trying to remember how you're setting this up is because there's a slightly different formula you have to memorize if you're going to rotate around the other axis, okay? So if you're going to rotate around this axis, right, then we're still going to have, right, we're going to have x is equal to some function, we're going to have y as some function of x. So maybe you'll have something like that you're trying to rotate. So in this case, it's pi, we'll say g of y squared dy, because all your little heights are these guys here, right? And then it gets crazy because sometimes it isn't about f of x or g of y rotating around the axis. You're going to rotate it around like x equals 2 or something, or y equals 2. So it's possible that you've got this function and you're going to rotate it around, like say x equals 1. All right? So you're going to rotate it around this one, not the way I've drawn it. Okay. You're going to do it around x equals 1. And that's going to be a little bit harder to deal with, okay? But you're also rotating, well, in this case, you're not. Okay. The other thing that could happen, and this is called method of washers, that's what we're doing here, is that you've got an outside radius and an inside radius, and you want to know what that is, okay? So we have to take the outside radius, or the outside volume, minus the inside volume. So if you've got like some kind of a contraption that you're trying to, you know, make a, you know, an outside thing with an inside bit that's drilled out of it, this is the kind of thing that we're going to be doing, okay? So you might have some kind of like an engine or something, and then really what we're doing is we've got this engine here, but you've got this inside piece, right? This is the part that's going to be hollowed out, and then this is the whole volume of solid, but you've got to minus this little hole in here, okay? So forgive my drawings, they're terrible, okay? The book has much better ones, but that's the idea of taking outside radius minus inside radius. Okay, so that's why like memorizing formulas for this, like it's going to get kind of messy if you're trying to do that. So I recommend like drawing the pictures and figuring out what you're doing rather than going through and doing trying to memorize everything. Okay, because especially there's a lot of formulas in Calc too. Okay, I'm sorry, but there is. There's a whole bunch of intervals you got to remember, and then we've got arc lengths, we've got volumes. There's just a ton. Okay, so I would recommend like kind of parsing it out and reasoning out what you're doing, and then going ahead and using cylinder formula and not trying to memorize everything. But I get it. The first couple of times, you're probably going to be memorizing it, which is, part of learning. It's okay. So why don't we just start with something, okay? So what if we have y is equal to x plus 1. This is not the first problem in your book because that's an example, but this is one of the first problems that you have, okay? And we are told to go from y equals 0 and x equals 0, okay, to, I guess we have y equals 8. And we are evaluating, so x equals 8, I think it's x equals 8 to x equals 8. All right, and we are rotating about the x-axis. All right, so let me just draw this poorly so we get an idea of what you're talking about here, because all of these problems are, the first time you see them, the second time you see them, the third time, they're a little bit rough. So what's the graph of y equals x plus 1 look like, right? When x equals 0, then y is up here at 1, right? And when x is sitting here at 8, then y is going to be all the way up here at 9. So it's just a line, right? But what we're doing, think about this as the cross-sectional area, right? And we're rotating this around the x-axis. So we're rotating all of this. So when you're done, right, it's probably going to look something like this. Right? So all we're doing is we're figuring out the volume of a cup, really. I mean, we're not taking out the inside, right? So if I had maybe a filled cup, right, what volume would that be? So that's really what we're doing here. Okay. So let's go through and do this. Okay. So here's my radius. Right. Here's my radius. My radius is equal to x plus 1, right? No matter where we are here, my radius is going to be x plus 1. And this thickness here, this is dx. Okay, now we're not adding up a whole bunch of rectangles like we did in Calc 1. That was tedious. But we are going to be using this idea of pulling out, like, how do you know where you're rotating around? How do you know what you're going to do with your function? All right. So what we're going to do is we're going to integrate. Right. We're going to add up all these tiny little slivers here. So we've got a pi. We've got an r here, right? We've got r squared. And r is equal to x plus 1. Okay. And then my h, right, for each cylinder, my h, my little tiny thicknesses here are my dx's. All right. So, and what are we going from? We're going from x equals 0 all the way up to x equals 8. All right. So let's just go ahead and simplify this down a little bit. So we've got pi. We can pull the pi out in front. We've got from 0 to 8, x plus 1 squared dx. And now you have some options, right? You could multiply this out. We could integrate x squared plus 2x plus 1. Integrate that. That's fine. We could also say let u is equal to x plus 1. That way du is equal to dx, right? So let's do that, because it lets me do this. Okay. So I'm going to do a u substitution here. We can change our limits of integration. You don't have to do this. This is a completely optional thing. If you wanted to, Integrate it this way here, you're going to get exactly the same thing. Okay. But when x equals 0, then u is going to be 0 plus 1, u is equal to 1. When x equals 8, why did I pick the 0 and the 8? Right? Then u is equal to 8 plus 1, 9. Okay. So when I go ahead and I put this over in the u space, we've got the integral of pi, 1 to 9, u squared du, right? Because du is just dx. So that's going to be pi times 1/3 u cubed, going from 1 to 9, right? So we have pi over 3, and then we have, here's the hard part, right? This is 3 cubed minus 1 cubed. And 3 cubed is, the heck is 3 cubed? Oh, no, 9 cubed. Delightful 729. So this is equal to pi over 3 times 729 minus 1. This is pi over 3 times 728. Okay, or I guess we could clean this up and say this is 728 pi all divided by 3. And that's my volume. All right. So that's what we're doing here. Okay, the calculus isn't always, not yet, will be. Calculus isn't always the worst thing when you're getting to this, but the idea of setting up the geometry and figuring out, like, what am I doing and what am I adding up? What are my limits? That's usually the hard part with these problems. I'm also going to tell you that, for all the people that know in calculus, this section and the following section, these are two of some of the hardest sections that you're going to meet for a while. So if you're looking at this and you're like, I don't quite get it, I need some more practice, you are not alone. Okay, everybody, when they get to this section, it's a little rough. Okay, so if you're having a tough time with this, you are not thinking, don't think to yourself, I don't belong here. This is way too hard. I don't remember this in Calc 1 at all. No, you don't, because we didn't do it in Calc 1. But you are not alone. A lot of people, most people who go through Calc 2, this section and the section that's right after it, these are some of the hardest sections that you have to deal with in quite some time. All right. So let's see here. How about we try another one? And we'll do a, this again, this is a pretty tame one to start off with. So that's x minus 1. Okay, x minus 1. And here we're going to go ahead and hit, what is this? Y is equal to 0 to x equals 6. All right. And again, we're going to rotate about the x-axis. Okay. So let's see what we got. See, when your math teacher in college algebra told you that you'd have to remember how to do this, you didn't believe him. You didn't believe her. Okay, so here's your function. Y is equal to the square root of x minus 1, right? And we're going to rotate this around the x-axis. So we're taking this and we're rotating it around. So this one is looking like, this is maybe a cup, but it's got pointing at the bottom. Okay, so it's not quite a triangle, but it's still a cup type of a shape. So here's my radius, right? My radius is equal to the square root of x minus 1. And my dx here, right? This little space in here. I'm adding up all of these little slivers in here. That's my dx. Okay. So what we're going to do is we're going to go from, right, 1 to 6, right? 1 to 6, and we have pi. And we have the square root of x minus 1 squared, because that's what we have to do, is square the radius times our height, dx. So this one I don't really need to use substitution for, do I? Because we have 1 to 6, put the pi out in front here. We have x minus 1 dx. Nice integral. Okay, we should all be so lucky. So here we go. We have pi. We have x squared over 2, right? Minus 2x, and we're going from 1 to 6. All right, and that's all there is to do with this one. You don't need a C. These are all definite integrals. Okay, so this is going to be pi. Let's see, I think I moved to, what did I write down 2x for? What am I thinking? It's not 2x, just minus x. All right, just minus x. So if I pull a 1/2 out, right, we've got x squared. Now I've got a minus 2. Put this back in. Do we get the same thing? Yeah, we do. And then we're going from 1 to 6. All right. So here we have, right, my volume is equal to pi over 2. That's these two pieces. And then we have x squared, 36, minus, right, 2 times 6, minus 12. Right? And there we have it. So what is this? This is pi over 2, 36 minus 12, what is it, 24? Okay. Yeah, I think we're good for that. And yeah, there we go. Okay. All right, that's 12 pi. All right. Oh, no, I'm not right. We're going from 1 to 6, not just 6 to 0. So stop me before I do arithmetic wrong here. Okay, 1 to 6. So here we're going to go back to here. Okay, we've got pi over 2. We have x evaluated at 6. Oops. Change the order of those things. Okay. So at 6, x equals 6. See, this is the hardest part, is the arithmetic. We have 6 squared minus 2 times 6. Minus x is equal to 1. 1 squared minus 2 times 1. All right. That looks a lot better. Okay. So here we have 20 pi over 2. We have 36 minus 12. Again, that was my x evaluated at 6 minus 1 minus 2. X evaluated at 1. Okay, so this is pi over 2. 36 minus 12 was indeed 24. And then what's this going to be here? This is going to be minus 1, isn't it? 1 minus 2. Minus a minus. There we have it. All right, so that's what we want to be looking at. All right, don't forget your first limit there. All right, so yeah. Let's see if we can't go around a different axis. All right, so here we have x is equal to 4 times the square root of 5y. We're going to go from x equals 0 to y equals 3. Rotate about y-axis. Not the x-axis, now we're doing the y-axis. So when I'm going to go ahead and draw this thing, right, this is, f of y is equal to x. So we kind of got to draw this thing sideways, right? It's still a square root function, but instead of drawing it as a square root function, right, we have to, in y, right, y equals some function of x, we got to turn it sideways. Okay, so 0, we'll say y equals 3 here. Okay, and we can plug this in, right? We can plug this in and get what our values are, but what we're trying to do here is get that value right there. Okay, we're trying to rotate it around this axis. Y is going from 0 to 3. Right? Y is going from 0 to 3. I know it says x equals 0, and they will tell you that way in the book, but if you plug in 0 here, right, plug in 0 here, y has got to be only one choice. Okay, so let's go ahead and set our integral up. So in this case, what's my radius? Right, the radius is the value of y at this point, the value of x at this point, and that is 4 times square root of 5y. Okay, And what we're doing in this case is we're summing up all of these little pieces, right? We're summing up all of these cylinders. Well, these are thickness, not dx. These are thickness dy. Okay, so notice when we're rotating around a vertical thing, then we're adding up a bunch of dy's. When we are adding up around a horizontal, right, a horizontal axis, we're adding up a whole bunch of dx's. Okay, so try to remember that. That is a tough thing to deal with, but that's how that's going to go. Yeah, abstract. Thank you. Okay. So be careful about that, where you're rotating around, and try to make sure you're using, like, where am I rotating to how do you want to define your function? Okay, so be careful about that. Okay, so so there we are. So what are we doing? We're going with y's, right? We have a dy, so my limits are going to be in y's. All right, and then we've got, here's our pi, and then we've got our r squared, right? But in this case, r squared is equal to some function of y. So let's plug in 4 square root 5y here. Okay, now you got, this is tricky, right? This one's a little tricky. So what we're going to try to do here, right, is say this is integral from 0 to 3 pi 4 squared, because everything in here is a squared, right? Everything in here is a squared. So we have a 16, and then the square root of 5y squared is just 5y dy. All right. So what are we doing next here? We are going to go off and say 16 times 5, that's 80 pi, 0 to 3. And what do we have? So we just have y dy left here. Okay, that's great. So this is 80 pi times y squared all over 2. Right? Now where are we going with this? Right? We're going from 0 to 3. So what do we have here? We have 80 pi, right? And then we have right, 3 squared. Let me go a little bit slower. Right, we've got 3 squared over 2 minus 0 squared over 2. So we have 80 times pi times 9 all over 2. So we can cancel out a little bit there and end up with 40 times 9 times pi, which is 360 pi. That is the volume of this cup with a pointy end at it. Okay, so that's what we do with that. All right. Right, so the next piece is they want us to take out a piece of the middle. Okay, so they want to know what's the volume of a solid bounded by y is equal to 7x and y is equal to 7x to the 4th. And they just kind of stop. They say rotated about the x-axis. Okay. And they kind of leave it up to you to figure some of this out. So we're going to rotate it around the x-axis, right? So we're rotating this way. I really want the x's because I want to add up, right, those pieces. All right, so I want to make, I'm okay with this being all right as is. All right. Which one's on the outside? Which one's on the inside? Okay, you might think this guy's on the outside, but where do they meet? Right? Where are they equal? So this is 7x minus 7x to the 4th equals 0. So let me pull out an x here, 7x. And then we have 1 minus x cubed equals 0. Where's that going to be true, right? That's 1 is equal to x cubed, x is equal to 1, at least on the real numbers. Okay, so this is only good between 0 and 1. Okay, well, 0 and here's 7. Okay. So again, which one's on the right, which one's on the outside, which one's on the inside? You can always pick a point. Right? And see which function is bigger, right? Is 7x to the 4th or 7x bigger? Well, if I plug this in, right, 2 to the 4th power, 1/2 to the 4th power, what is that? 1 over, it's 2 to the 4th is 16, I think. So that's 7/16. And what is this one? 7/2. Which one's bigger? That one. So when we go ahead and graph this thing, right, here's my 7x. And then here is my 7x to the 4th. Okay, it's underneath. So it's going to be outside function minus inside function. Okay, so what we're doing here, right, is we're getting some kind of a shape like this, rotated around the x-axis. Okay, so I suppose this thing kind of looks like a flower or something. It's probably something that it could look like, but you know, we have outside minus inside function. All right, let's see what that's going to look like. So we have 0 to 1, right? We have a pi. Technically, this is what we have here. We have a pi big function h minus a pi little function. Okay. So we have big cylinder minus little cylinder. There's some stuff that factors, isn't it? Right. So that's generally the form your book will use. Is they'll do something like they'll almost automatically jump into something like this, but that's where this comes from. Okay. So we have pi. What's my outside function? Right. That was 7x squared minus what's my inside function? 7x to the 4th squared. Yeah. The x. Right. Again, not terrible integrals, right? Not terrible integrals. It's pi 0 to 1, 7x. Let's go ahead and simplify that. So that's going to be 49x squared minus squared, right? Squared. So 7 squared is 49. And then this is x to the 8th. The x. And then we're going from 0 to 1. All right. Pi. 40. Actually, I can factor out 49 too, can't I? Maybe we should do that. When I integrate x squared, we get x cubed over 3. When I integrate x to the 8th, we get x to the 9th over 9. And we are running from 0 to 1. Okay. When I plug in 0 here, is there any surprise that this stays to be 0? Right, we have 0 minus 0 times whatever, 0. When I plug in 1, right, we have 49 pi. What I have here is 1/3 minus 1/9. Okay. So 3 times 3, we get 3 over 9 minus 1 over 9. And that is 49. What do I got here? We've got 49 pi. And we've got times 2/9. Okay. 49 times 2, that is 98 pi over 9. And that is the volume of that kind of weird, you know, cone type thing minus the polynomial type thing in the middle. Okay, so that's what you do with those. All right, let's try another one here. What are we rotating this about here?
In class?
Okay, this is a good one. So I've got two functions. Right, trying to trick us, right? We got y equals x squared, x equals y squared. And again, we want to rotate this around. Y equals 1. Okay, so this is why you want to draw this thing out, because this is a confusing problem. Okay, and if you're looking at this and thinking, well, it's a little rough, like, you're right, this is a little rough. Okay, what does y equals 1 look like? That's here, right? So whatever we're doing here, this is where we're rotating. Okay, would it make sense to use dx's or dy's if this is going to be the rotation here? So I think my height's still going to be dx's, because whatever I've got, whatever kind of weird shape I end up with, we're going to cut it into pieces like this. Okay. So now we have to go ahead and say, well, let's go ahead and graph it. Like, oh, I can graph y equals x squared. That's not too bad. What about x equals y squared? Like I said, they're trying to trick us. It's the same function, right? We've got here, right? This is y equals root x. Here is y equals x squared. Okay. Now we're still trying to rotate it around this one up here. Okay. So if this is my axis of rotation here, okay, then that one, hold on, let me do it this way. Red could be a nice outside function. This is going to be your outside function, right? Your outside radius. And let's go with green. This guy in here, right, is going to be your inside radius. Okay, so we have the outside minus this inside thing. Right, I would not even try to attempt to draw this thing as a part. Okay, that's what, you know, but we're going to have something like this, and then we're rotating it around here. Okay, so what does my outside function look like? Well, the outside function, right, the radius here, is 1 plus x squared, isn't it? Because it's 1 plus x squared to do all of this. No, I'm sorry, it's 1 minus x squared. We have 1, and then we have to take out a little bit here. Right, so it's 1 minus x squared. The inside one, right, that's going to be, if here's 1, and then we're going to subtract off this piece. Okay, so the inside is 1 minus the square root of x. All right. You have to do a couple of dozen of these to get the idea of where you're rotating around. Okay, these are not the easiest problems. And even though I know it looks extremely difficult right now, it's almost customary that when you face your first Calc 2 test, one of them is going to be like around an axis that isn't this axis. Now, one of them will be around one of these axes, but one of them is going to be around an axis. It's not just the first one. Okay, so definitely when you're doing your homework, try to practice a couple of these that are a little bit offset. Okay. They're not all going to be like this. These are hard, and they take a long time to set up. but one of them is going to be like, well, it's not, and it will always be like an x equals or a y equals a constant. Okay, there's a YouTube thing where somebody tries to rotate around x equals y. It's nuts. So that is not a fun problem to deal with. This is not a good test question. All right, you can think about this one, but I even like this one as a project because like everybody pretty much ends up looking it up on YouTube anyway. But and it's tough. It's a tough one. Okay. So we have our outside function 1 minus x squared. Right? We have 1 taken away a little bit, 1 minus taken away a little bit more. Okay. So we have integral. We're going from 0 to 1, aren't we? That's where these two are going to intersect. Here's my pi. Here's my outside squared minus, here's my inside squared. Okay, dx at the end. All right. Now, you're very happy that you took algebra so many years ago because this is going to be delightful, isn't it? This is going to be good. So, pi, okay, wish me luck. Okay, 1 minus 2x squared, right? Because the 2 x's in the middle, plus x to the 4th. That's the first one, squared. Minus 1 minus 2 square root of x's, right? That's what's there, plus x. That's what we have. All right. Not the worst thing in the world, not the best thing in the world. So what do we have here? We have a 1 minus 1. Hey, that cancels, doesn't it? So that's good. Let's use red. We'll cancel that. I don't think the rest of this is canceling. So we're kind of screwed on that one. All right. So we have pi. I have a positive x to the 4th. I'm just going to put them in descending order here. Minus 2x squared. Okay. Minus, right? Minus x. Don't forget the sign here. And then plus 2 root x. Again, 0 to 1 dx. Now the setup part is done. That was hard. That was the hardest part of the problem, was that setup. And we get to multiply all this stuff out so we can do the calculus. But this calculus, right, this is a Calc 1 problem for us, isn't it? This is not so bad. So this is pi. This is even nice because it's 0 to 1. I don't even have to think about what's going on over here. Right, so that's going to be add 1. So that's going to be x to the 5th over 5, right? Minus, we're adding 1, so that's minus 2, x cubed over 3. Minus, adding 1, that's a 1 there. That's x squared over 2. Plus, this is x to the 1/2, right? So if I add 1 to it, we're really adding 2 halves. So that is 2x to the what? 3 halves divided by 3 halves. And then we're going to clean this up in a minute here. Okay, what are we doing? We're going from 0 to 1. Okay, so this is pi. We have x to the 5th over 5 minus 2 x cubed over 3 minus x squared over 2 plus, and remember what happens here, right? We have a 2/3, so that cancels. So we have a plus 4/3 x to the 3 halves. 0 to 1. You can see, right, when I put in 0 for all of this, it all disappears. It's not like I have a cosine over here or anything like that. Put in a 1, you're all set. Okay, so here we have pi. We have 1/5 minus 2/3 minus 1/2 plus 4/3. All right. I hope that was okay and going that fast was okay. I get that you guys are just coming back off of a break, and arithmetic is integrals and all of that stuff it's a little bit rough still. Okay. So what do we have here? We have 4/3 minus 2/3, so that's pi 2/3, right? Minus 1/2 plus, And then we can get common denominators and kind of work this thing out. I'm going to show you a little cheat. Why didn't you cheat before? I don't know. Just didn't. All right, so this is 2/3. Okay, minus a half plus a fifth. And then what I'm going to do is I'm going to go to math here and see this fraction. That's what this does. It converts it to a fraction. So it's 11 pi over 30. All right. So if you have to put things back into a fractional form, like we used to, here's the way to cheat. When I say cheat, I don't really mean cheat, but here's your way of kind of shortcutting that deal. If somebody comes by and says, wow, you're really good at fractions, it's like, yep, Calc 2 does that to you. Just don't say a word. Okay, you think I'm brilliant. That's good. Go on with your life. Let them think that. Okay. All right. Let's see here. All right. I don't want to go too much longer, but let's do one more just for the sake of getting that done. Okay. So this is y is equal to 27x cubed. And we're going to go from y is equal to 0. We're going to have x equals 1. And we're going to rotate about x equals 2. Okay. What does the line x equals 2 look like? So here's the bound of the function, right? This is where my function is. Here's x equals 1, x equals 2. So we're rotating this way. So when I've got my pieces out here, right, we're going to rotate around this way. And what are all these little heights going to look like? They're going to look like dy's. So y equals 27x cubed. Right? Let's go ahead and draw that in there. We won't keep it, but we're going to draw this in here as it is. Right, when x equals 1, y is 27. We'll pretend this is the scale. So what are we going to see here, right? We're going to see this little thing on the outside, and then there's going to be a huge gap in here as it's being rotated around. And then on the other side, we're going to have something like, pretend these two match, okay? But that's kind of what we're going to have here, all right? So we've got like this huge, I guess, intake valve or something. So we're going to have something like this. And it's all rotating. And that's the shape we're going to have. So it's going to be in two pieces, right? This is going to be a two-piece kind of a shape. They don't care. All right. So that's kind of what this thing is going to look. All right. So I got y equals 27x cubed, but I'm going to need a x equals something to integrate because we have a dy. Right? So I really want x equals some function of y here because that's the way this integral makes sense. Okay, you don't want to have y equals f of x dy. That's, we're not there. That's not going to work out for us. We need something like this. Okay, so even though y is equal to 27x cubed, right? X cubed is equal to y over 27, and x is equal to, right, y to the 1/3 over 3, right? 3 cubed is 27. So we've got something like this. All right. Now, what we're going to do here is we are going to try to figure out what the heck the shape is. What's the inside? What's the outside? Okay. Here is my outside function. Okay. It's 1 plus this part, isn't it? Oh, it isn't. It's, how about we do it this way? it's going to be easier to go this way. It's going to be 2 minus that bit there. Okay, so this is 2 minus this curve. Okay, so this radius here, this is 2 minus the cube root of y over 27. Okay, and that's my outside bit. It's 2 minus this thing. Okay, and then my inside function, do that green. Might be better to see it. Right, my inside function is this. Here's my inside radius. Right, so we're taking this big thing over here in red minus this very easy thing in green, but this is my inside. Okay, sorry about my heater. So this is outside minus the inside. Right? Again, if you're looking at this like, wow, I'm not catching this at all. It's not going to click until you start doing a few, honestly. And even then, it's not really going to click until you've done a few dozen. So I get that these are confusing. I get that these are hard to set up. Okay. And I guarantee you, you'll have one that's like about this hard, or what we did above, or one about this hard. Okay, so that's about, and I would not, I don't want to make them any harder than that. This is hard enough. It does not need to be harder. Okay, so I will put you, there is going to be one where it's around the different axes, but there'll only be one. Okay, all right. So what are we doing? We're going with y's, right? We're going with y's. We have a dy. So what are my y's going from? Y's are going from 0 to 27, aren't they? Y's are going from 0 to 27. And what's my outside radius? That was 2 minus, right? Y to the 1/3 over 3 squared. Okay, again, delightful. This one's nice. All right, it's 2 minus 1. Okay, so so this one, yeah, we've got to figure out this bit here. This is not going to be so bad. All right, so this is going to be pi 0 to 27. Okay, I can't multiply this one out in my head. Well, maybe I can. All right, we have what? What is this? 1/3 y to the 1/3, and then 2 minus 1/3 y to the 1/3. So what is that going to give us? It's going to give us 4 minus 2 thirds y to the 1/3, right? Because there's 1, 2 of these. Oh no, there isn't 2 of these. These are 2/3 and 2/3. 2/3 and 2/3 would be 4/3. And then we have plus, right? Because times negative, and this is going to be 1/9. Y to the 1/3 times y to the 1/3 is y to the 2/3. Minus 1. 2 minus 1, square it, it's 1. All right, so 4 minus 1, 3, minus 4/3, y to the 1/3, plus 1/9, y to the 2/3. dy, y is out front. Okay, see, delightful. All right. So now it's time to do calculus. All right, after all that setup, now we can do some calculus. So 3y minus 4/3. Now we have to add 1, right? 1/3 plus 3/3 is 4/3. So this is y to the 4/3 divided by 4/3. I see something that's going to happen here. Plus 1/9. We're going to add 1, right? That's what we do for integration, is we add 1. So 2/3 plus 3/3, that's going to be y to the 5/3. All right? I think that counts for everybody. We're going from 0 to 27. All right, to simplify this, right, we have pi, we have 3y. Do you see that 4/3 divided by 4/3 is actually just 1? So this is going to be minus y to the 4/3. Now this is a mess. This has got to be delightful. So that's a 3 there, so this is 1/15. Okay. So it's just 1/9 divided by 5/3. Do it however you please to do that. Okay. So that's going to be 1/15. That takes care of that. And then we have y to the 5/3 from 0 to 27. Okay. Well, fortunately, if I plug in a 0 here, that's all going to be 0. So the only one I really have to worry about is this 27. Fortunately, the cube root of 27 is 3. Okay. So here's my pi. We have 3 times 27. It's going to be 81. Minus 27 to the 4/3 plus 1/15, 27 to the 5/3. All right. So what do we have? We have 81, because 21 times 3 is 81, minus cube root of 27, what was that, 3? And 3 to the 4th was 81. And this is going to be cube root of 27 is 3, and 3 to the 5th is 243. So there we go. We have 243 over 15 pies. Just what you expected, right? Sure. Okay. I know that is a hard problem. I do. Okay, that's not easy. Of the two, if you said you have to pick a test question today, I don't. But if I had to, it would lean a lot closer to this one, because the chances of having a mess up and having a weird thing to grade is a lot higher here than it is on this one. Okay, so practice these because they are hard, but also understand they're not, I'm not trying to find the hardest one of these things to pick for an exam, because that is terrible. Okay, so I'm trying to find one that's, that's fairly tame, but still has a rotation around an axis that's not the x-axis or y-axis. Okay, now we get one of those too, but not everything has to be the hardest problem. Okay. All right, so that's what we have for that. I'm going to stop recording, and that way, if you guys have a question you just want to ask, you can. But